Unraveling the Power of sklearn's Random Forest Regressor, a comprehensive guide. The Random Forest Regressor in scikit-learn is a powerful ensemble learning method used for regression tasks. It builds upon the core idea of decision trees, combining multiple trees to achieve a robust and accurate prediction. This guide will delve into the intricacies of this algorithm, shedding light on its inner workings and guiding you through its implementation. 1. Foundations decision trees. Before diving into the forest, let's understand the individual trees. Decision trees are hierarchical structures that partition the data based on features, creating a series of yes-no questions leading to a final prediction. How they work: a decision tree starts at the root node, where it chooses the best feature to split the data based on information gain entropy reduction. This process recursively continues down the branches, creating nodes and leaves. Leaves represent the final prediction, while nodes represent further splits. 2. The ensemble advantage: random forests. Instead of relying on a single decision tree, a random forest builds an ensemble of multiple trees, each trained on a different random subset of the data and features. This brings several benefits. Reduced overfitting: each tree learns from a unique perspective, reducing the risk of overfitting to specific data points. This ensemble approach promotes generalization and better performance on unseen data. Improved accuracy: by combining multiple predictions, the random forest averages out individual errors, leading to a more accurate overall prediction. Feature importance: random forests provide insights into the relative importance of each feature in the prediction process. This information helps in understanding the underlying relationships within the data. 3. Building a random forest. Key parameters. The Random Forest Regressor in scikit-learn offers various parameters to customize its behavior and tailor it to specific datasets. Nestimators: this parameter controls the number of trees in the forest, increasing the number generally improves accuracy, but at the cost of increased computational time. Max depth limits the maximum depth of individual trees. Limiting depth can prevent overfitting and improve the model's generalization ability. Min-sample split determines the minimum number of samples required to split a node. Higher values lead to less complex trees, potentially reducing overfitting. Min-sample's leaf sets the minimum number of samples required to be at a leaf node. Similar to min-sample's split, higher values lead to simpler trees. Max features controls the number of features considered for each split. This parameter can be a fraction of the total features, a specific number, or auto using the square root of the total features. Bootstrap: this parameter determines whether to use bagging, a technique that randomly samples data with replacement for training individual trees. Setting it to true default introduces more diversity within the forest. 4. Implementation in scikit-learn. Using Random Forest Regressor in scikit-learn is straightforward. Python. From sklearn, ensemble import Random Forest Regressor. From sklearn, model selection import train test split. From sklearn, metrics import mean squared error. Load your data. X. Your features. Y. Your target variable. Split the data into training and testing sets. Xtrain, Xtest, Ytrain, Ytest. Train test split X, Y. Test size 0.2. Random state 42. Initialize the Random Forest Regressor. RF Random Forest Regress on estimators 100. Random state 42. Train the model on the training data. RF. Fit Xtrain. Ytrain. Make predictions on the test data. Ypredrf. Predict Xtest. Evaluate the model performance. MSE mean squared error test. Ypred. Print mean squared error. MSE 5. Advantages and disadvantages. Advantages. High accuracy. Random forests often achieve high predictive accuracy, especially on complex datasets. Robust to outliers due to the ensemble nature. Individual tree errors tend to be averaged out, making the model more resistant to outliers. Feature importance provides insights into the relevance of features for prediction. Handles high-dimensional data, effective in handling datasets with numerous features. Disadvantages. Black box model. The decision-making process can be difficult to interpret due to the complexity of the ensemble. Computational cost. Training a random forest can be computationally intensive, especially with a large number of trees and data points. Overfitting on small datasets. Although less susceptible than individual trees, random forests can still overfit on small datasets, especially with high estimators. 6. Tuning the model for optimal performance. Finding the optimal parameter configuration for a random forest model requires careful consideration of the specific dataset and performance objectives. Grid search. Utilize the grid search CV class in scikit-learn to exhaustively search through a grid of parameter values and find the best combination. Random search. Employ the randomized search CV class to randomly sample parameter combinations, which can be more efficient for large search spaces. Cross-validation. Employ techniques like k-fold cross-validation to evaluate the model's performance on multiple folds of the data, providing a more reliable estimate of its generalization ability. 7. Further exploration. Extending the model. Explore other ensemble methods, such as gradient boosting machines, which can be more powerful but require careful tuning. Feature engineering. Spend time exploring feature engineering techniques to create new features that capture valuable information and enhance the model's predictive power. Model interpretation. Employ various techniques to understand the model's predictions and gain insights into the decision-making process. Conclusion. Sklearn's Random Forest Regressor offers a powerful tool for regression tasks. It combines the strengths of decision trees with ensemble learning to achieve robust and accurate predictions. By understanding its workings and skillfully tuning its parameters, you can harness its potential to build effective models for various data-driven applications.